Hello and welcome everyone to Tech Shots. My name is Milind Kulkarni. I have about 3 years of experience and currently I work as a data engineer at Velotio Technologies. As part of my role, I work around various databases and data warehouses and build ETL and ELT pipelines and some other stuff. Today we'll be discussing one of the newest tool in our big data arsenal, ClickHouse. This will be a series of videos, and in this part, we'll be covering basics of ClickHouse, what exactly it is, what are its features, and how it measures up against some of its competitors. So let's begin. ClickHouse was developed many years ago at a Russian tech giant called Yandex. Yandex is world's second largest web analytics platform after Google Analytics. They later open sourced ClickHouse under Apache license, encouraging its adoption in community and increase in contributions by community. ClickHouse is open source, column-oriented data warehouse, which is primarily used for analytical processing of queries. It is fast, scalable, flexible, cost-efficient, and easy to run. It allows creating tables and databases in runtime. It can process billions of rows across hundreds of nodes at a rate of tens of gigabytes per second per server. The peak processing performance for a single query in ClickHouse stands at more than 2 terabytes per second, which is fast. Several tech giants have migrated to ClickHouse, some of which are Uber, eBay, Spotify, and ClickHouse. After migrating to ClickHouse, Uber saw 10 times increase in performance, 3 times data compression, which improved their storage efficiency. They saw 50% reduction in hardware. So that's nice. eBay similarly saw 10 times reduction in hardware. ClickHouse has a stronger integration with Grafana that helped them reduce their DevOps activities and troubleshooting. After migrating to Spotify, is now serving thousands of subsequent queries on petabyte scale datasets. They have reduced their low variance work, which has enabled their teams to self-serve insights. Cloudflare, after migrating to ClickHouse, has scaled their system to serve 8 million requests per second and have seen 7 times improvement on query throughput. So what exactly makes ClickHouse unique? Why is it so fast? So ClickHouse does not separate storage from compute. It works on hard drives, but it can also use SSDs and RAMs, which allows it to be even faster. It has general purpose and specialized compression codecs for certain kinds of data, which allows us to further improve storage efficiency. ClickHouse is vector computation engine, which, whenever possible, tries to apply operations on chunks of columns or vectors. By doing this, it helps ClickHouse to lower the cost of actual data processing. ClickHouse allows parallel processing across multiple cores, and it also supports distributed query execution. Data is sorted by primary key in ClickHouse, and it also supports secondary indexes. Secondary indexes or data skipping indexes in ClickHouse enable ClickHouse to skip reading significant chunks of data that are guaranteed to yield no matching values, which reduces reads and hence improves the query performance. Approximated calculations. So ClickHouse uses approximated calculations by which it executes a query based on a part of data or a sample of data and gets an approximated result. By using approximated calculation, ClickHouse executes a query based on part of data or sample of data and gets an approximated result. By doing this, ClickHouse trades accuracy for performance as it's retrieving proportionally less data from the disk. ClickHouse uses a synchronous multi-master replication. After being returned to any available replica, all the remaining replicas retrieve their copy in the background asynchronously. The system maintains identical data on different replicas. Recovery in case of failures is done automatically, and in complex cases, semi-automatically. So not even ClickHouse is perfectly flawless. It has some of its disadvantages, which are no full-fledged transactions. It lacks the ability to modify or delete data that is already inserted with a high rate and low latency. There are batch deletes and updates. Initially, it didn't even support updation and deletion, but later, to comply with GDPR and to clean up, they added the support to batch process, batch delete and update data. ClickHouse by their keys. ClickHouse is optimized to work on a chunk of columns or vectors, due to which sparse indexes in ClickHouse makes it not so efficient for point queries. Let's compare ClickHouse against some of its competitors. So Redshift and Snowflake are few of the popular OLAP data warehouses. They are also columnar. So let's see how they're. In terms of deployment, ClickHouse is primarily deployed on-premise, but it can be deployed in cloud. It does not have its own cloud like Snowflake, but yeah, we can deploy it on cloud. Redshift is a cloud data warehouses. It is fully managed by AWS. Snowflake is also cloud only. In terms of scalability, if it is deployed on-premise, scalability is a manual thing. You will have to manually hardware. And if it is a cloud deployment, it can be scaled easily. Redshift can be scaled easily because of it being on AWS, and similar to Snowflake, since it's on cloud, it is easily scalable. Storage and compute. As mentioned, it has coupled storage and compute, unlike Redshift and Snowflake, which have decoupled storage and compute. Indexing. ClickHouse supports secondary indexes, while Redshift and Snowflake do not support indexing at all. Pricing. ClickHouse is cheaper compared to Redshift and Snowflake, which can be priced moderate to high based on your system. ClickHouse engines. So ClickHouse has engines to store data. Depending on type of your table and data, ClickHouse provides an array of engines that help you to connect with different databases and also determine the way data is stored, accessed, and other interactions on it. These engines are mainly categorized into two types: database engines and table engines. Table engines are further categorized into different families based on the certain parameters. These families are MergeTree family, log family, integration family, and special engines. So let's have a look at these families. MergeTree engine family. So these engines are most universal, and these are widely used for their high load tasks. They support quick data insertion with subsequent background data processing. They support data replication, partitioning. They also support secondary data skipping indexes and a few other features. Some engines of this family are MergeTree, summing MergeTree, and aggregating MergeTree. Let's have a brief look at the architecture of this MergeTree engine. So let's have a look at MergeTree engine in ClickHouse. So data is logically divided into partitions in ClickHouse. Each partition consists of multiple parts. Each part is made up of small granules, which is a group of columns for one row. Each part in ClickHouse has its own directory, within which there's a mark file and there's a binary file, which can be seen as .mrk and .bin. These mark files are cached on LRU basis and usually take very less data, so it's faster to process them and find them. Based on these mark files, it identifies the binary and retrieves data. ClickHouse implements MergeTree to optimize the number of parts, because larger the parts, more efficient ClickHouse is, and it will have to maintain less dictionaries. MergeTree gets dynamically updated whenever data is inserted, updated, or deleted. That's why it is important to insert in larger batches, as ClickHouse will spend lesser amount of time to merge them. Due to implementation of this mark and bin files, ClickHouse can identify a certain set of row that needs to be fetched based on your query, and it will only point to those binaries and retrieve them. So it's very fast and optimized to process your queries faster. The second family of engines is log engines family. These are lightweight engines and have very minimal functionality. Some of them don't even support, like the log engine does not even support concurrent execution. Log engines work best when you need to write small tables and read them later. Some of the engine in these are log engines, TribeLog, and TinyLog. TinyLog and TribeLog support concurrent execution of queries. Integration engines. So integration engines in ClickHouse are used to fetch data from an external source, basically integrate with an external source like JDBC, MongoDB, SDFS, S3, Kafka. For example, if we use Kafka engine, we can configure a ClickHouse table to point to a Kafka engine which will ingest data as it is inserted inside the Kafka queue. And another example could be S3 engine, which allows ClickHouse table to access over S3 objects. These are primarily used when you want to import or export data from a different source and to a different format. ClickHouse offers some special engines that are specific to the use case. For example, materialized view. Materialized view in ClickHouse are built on top of tables, and unlike normal views, they store actual data. So these are used whenever there are some aggregations applied on your table and you don't want to apply them over and over again manually. Materialized views can be refreshed automatically after a certain interval, and whenever there are insertions in your table, it refreshes and you can have aggregated data in your view. Distributed and merge. So they don't actually store any real data. These engines are used to retrieve data that is distributed across a certain number of node or a cluster. And merge is the inverse of that. Like whenever you want to merge data that has been distributed across several nodes, you can use merge engine. To sum it up, ClickHouse is a very powerful, feature-packed, cost-efficient open source tool which is tremendously versatile. We saw a high-level comparison of ClickHouse with some of the best choices. ClickHouse applicability in web analytics, network management, log analysis, time series analysis, asset valuation in financial markets, and security threat identification makes it tremendously versatile. By consistently solving business problems in a low latency response for petabytes of data, ClickHouse is indeed one of the faster one out there.